Assalamualaikum. Good morning. I'm Khairul Anwar. Cover noise pollution and soil erosion assessment under me is a project. Give it sweet for poets. Leadership. For this topic, referring mostly on two books: mental noise pollution, noise mapping, public health and policy by Enda Murphy. You can also download it from EDIP. The other one is Advanced Air and Noise Pollution by Lawrence. Another one is Mental Management. What is thing number 3? Slack is available in EDIP. So what you will learn is fundamental principle of concept of environmental noise, uh, technical characteristic, some definition related to noise pollution or sound in general, review of existing evidence based on the health effect of environmental noise on human, then the technical approaches for noise mitigation. So for noise pollution, I think cover for 2 weeks. Soil erosion. So the debate challenges. This is based on environmental noise pollution books. It starts with an article in New York Times that explain behind the city in full deal calculate high and low. So the author described the everyday subjugation of New Yorkers to various sources of environmental noise. We have the road, the traffic noise, then at night the construction activities, helicopter, plane, and many more. So the manifestation of noise exposure as emotion in human is incredibly subjective. Even though the psychological impact are broadly similar, later we see the impact of noise uh, to health. So historically, the first noise abatement ordinance in there's event carried from the street of Rome during the night because citizens could not sleep. However, it is Greek affiliated with the first noise abatement ordinance in the first century before Christ. The band waters Smith as well as Rooster from residential area of DRC. So this is the first ordinance. Back to New York, relatively young city. The fight against noise has been ongoing for over 100 years, even during the Constitutional Convention that resulted in US Constitution, where they put dirt and straw to cover the cobblestone street to reduce the noise level. So in Malaysia, we have National Safety Act 1994 Amendment 2022, that recently had Noise Exposure Regulation 2019. So environmental noise. The characterization of sound as noise is quite subjective depending on the individual exposed. Noise is generally referred to as unwanted sound that significantly disrupt human or animal life. The alternative description is based on the physicist George William Case 1931 definition of noise as sound out of place. It is sound that is unwanted, inappropriate, interfering, distracting, and irritating. It is based on George William description of noise. So in definition, environmental noise is a form of pollution, defined as any unwanted sound created by human activities that is considered harmful or detrimental to human health and quality of life. So principle of environmental noise. So chapter 2, the noise pollution. So we start with the theoretical part. We'll go further to do your basic. You have already known this. Can relearn. A sound is the result of a pressure vibration in medium, typically. Okay, meaning there's a pressure fluctuation. Now, I'm speaking to you. So that is above and below the atmospheric pressure, which is 1 atm. So this detected by the human ear and result in the sensation of the hearing. So meaning the sound can also propagate through solid structure and water. You should be familiar with sound navigation and ranging system or sonar. The ship used to detect object under the surface of water. So this is the fluctuation of pressure over time. The sound as a wave. So vertical correspond to the pressure fluctuation, the y-axis. Pressure in Pascal, while the horizontal axis represent time. So all sound have three fundamental characteristics: frequency, amplitude, and wavelength. The frequency of wave f is the number of oscillation per second or cycle per second. The So also have three fundamental characteristics. Okay. So we have period, amplitude, frequency. So the time taken to complete one oscillation repetitive cycle is called the period T measured in second. Frequency is related to the period by F equal to 1 over T. But the amplitude of a wave is measured by the maximum value of pressure in the vertical direction equal to figure 3.1. This one is also equal to figure 2.1. Meanwhile, the wavelength lambda is the distance. So you see the difference here. The x-axis now is in distance length. The distance measured in meter traveled by a wave in one oscillation. So if it's in time, over time, sorry, so you can calculate the frequency, but between the peak, it's a period. If the x-axis in distance length, between the peak is wavelength. For sound wave in A, the speed of sound generally lies to 350, 345 meters per second. So the speed of sound denoted by C allow us to develop a relationship between the period measured in second and the wavelength measured in meter. Because there are two graphs. We have figure 2.1, figure 2.2. The difference is x-axis. If you want to develop a relationship between these two, wavelength and period, can do so by the speed of sound. So for a body in motion, distance equal to speed multiplied with time. So speed is equal to distance over time. So the speed of sound C may be calculated from C equal to lambda over T, but F equal to 1 over T. Therefore, C equal to F lambda. So it followed that a sound wave frequency 1,000 Hertz has a wavelength of approximately 0.343 meter. The relationship C equal to F lambda always hold no matter uh, what the speed of sound. This is still the definition. Otherwise, later on when we discuss, it's hard to follow the discussion. Now is the frequency. So noise is generally made of a range of different frequencies and not just a single frequencies. Average healthy human ear can detect sound from about 20 to 20,000 kilohertz. When dealing with ultrasonic noise, we're really interested in sound above 20,000. So that's why if you see the equalizer in your phone, in your car, The highest frequency is 20 kilohertz. The lowest is, yes, 20 hertz. And often it's a certain frequency below 20 hertz, which is the infrasonic frequency. Humans tend to feel infrasound rather than hear it. So this belongs to low frequency issues. Low frequency in the spectrum. So this is amplitude versus frequency. So figure 3.3a is the spectrum of a single tone represented by the red line. This is the full spectrum across range of frequency. So those who music background, they know about this. Frequency version may be displayed on the graph called the frequency spectrum. It shows the amplitude of the different frequency contained in the sound source. So for a pure tone, the spectrum simply dictate amplitude at a particular frequency. So in practice, there are frequency across the entire frequency range of interest, and the amplitude of each is shown in the spectrum. In this case, to pick observe, observe. This could represent the electric frequency of a system in some of this frequency. So, so we have octave band. So certain situations require analysis of the frequency content of noise instead of the overall noise level. This requires information expressed across the frequency range. So octave band are used to group together different frequency in a sound. So the frequency information can be analyzed easily. So the octave normally is a center frequency. If you can see here, it's a yeah. Oh, what gandaan, the first one. 63, 125, 250. It's a trend. So when dealing with octet band, we identify each by center frequency. So this is the octave band. So octave band based on the frequency. Because frequency, there's a peak. So we choose the center frequency. Next is the decibel scale. So sound is commonly measured using the decibel scale or dB. Would say the decibel is a ratio of one pressure to another. So possibly it uses a logarithmic scale and thus reduce a large range of information down into something more manageable. So LP equal to 10 P over P naught to square dB. P is the sound pressure being measured in P naught is the different sound pressure in P micropascal. The reference sound pressure corresponds to the lowest sound pressure constitution in detect in thousands. So we have a logarithmic scale because the decibel is a logarithmic scale is well to summarize some movement. Simple, this is just basic, just to show that if it's log 10a plus log 10b, we can simplify or equal it to log 10a multiplied with b. If it's minus, it's log 10a over b. If you raise a logarithm to a power, this, so you can break the power front log 10a power of n, so equal to n multiplied with 10a. Just some scale function. Okay, this is about the about the sound. The sound pressure level LP, we have sound pressure level LW, it's sound intensity level LI. The sound pressure level, LP is the level of sound, expressed in decibel relative to the threshold of hearing. And while the sound power LW is the acoustic energy emitted by a sound source over time, and it's a property of the sound source alone. It is measured in terms of watts. Sound intensity is a quantity that describes the rate of flow of acoustic energy projected in a certain direction. Because intensity has a direction associated with it, it is a vector quantity. So sound intensity, Li, if a sound power W passes through an area S, the sound intensity is equal to W over S, expressed in watt per meter square. Now consider a sound point source propagating in open A. Its energy will be spread out in the shape of a sphere. The size of the sphere will increase further the sound propagate. Propagate means it's move from the source. The surface area of a sphere is given by A equal to 4 pi r square, which is area of a sphere where r is the radius. So the sound intensity at the distance r from a point source of sound power W is given I by I equal to W over 4 pi r square, because S is an area. See, I know S should be A, but yeah, we spoke using S. So S is referred to the area. So it's a sound propagate without any blockage. So it's like a sphere. Sound pressure versus sound power. A vacuum cleaner switch on. This is page 20, chapter 2. A vacuum cleaner switch on and rest on a chair in the center of a room. Take a sound level meter and measure the sound level directly in front of the vacuum cleaner. 2 meters from the side of the vacuum cleaner, 3 meters behind the vacuum cleaner. The measure is quite different. Because this is because what you have just measured is the sound pressure level is dependent on the variety of external condition. Just true, yes. Every noise is a source, and the source of noise in this case the vacuum is described in terms of the sound power level. So in environmental noise study, the sound source is referred to in terms of the sound power level is the sound pressure level that is measured with the distance from the source. So the source itself is the sound power level. The distance between that source, we call it sound pressure level. So working with the decibel, because the decibel is in logarithmic scale, you put it just now, the decibel level cannot be added, subtracted in the normal arithmetic fashion, but the decibel must be added logarithmically. That's why I show you the logarithmic scale. So that's two sound level, L1 and L2, are added together in the following way to get a total sound level L total equal to 10 log 10 in bracket 10 to the power of L1 over 10 plus 10 to the power of L2 over 10. This is the example why we cannot get added it normally. A sound level meter measure the sound level 1 meter away from an idling lawnmower. It record the noise level as 60 decibel. Now a second lawnmower with the exact same sound power as the first is turned on beside the sound level meter again at 1 meter away. What sound level would the meter now record? So it is reasonable to assume that sound level meter is subjected to two noise source, both resulting in decibel at the position. If we were to sum it, normally it should be 120. But if you follow this method, increase in decibel is around 63. So you have to learn more, each tribute to 60 decibel. If you add it up, it's 63 decibel. So this is the A weighting, the units. Okay, the human ear does not respond equally to sound at different frequency. We tend to perceive sound at the lower frequency as having a lower intensity. Mm, this is explanation about, you see the dB decibel. Normally, it should be associated with this A weighting curve because of the first point here. So the unit will turn to dBA for A weighting, dBc for the C weighting letter, then dB. So dB is referred to dB. That's what dBz, which is no weighting. So the dB alone is no weighting. So on 1,000 Hz, then another 500 Hz, and the subject was asked to adjust the second tone until it was perceived as being the same intensity as the first. Then they repeated the experiment for a variety of frequencies and intensities and developed equal loudness controls for each intensity. So A weighting, which is commonly used in environmental noise study, was developed as a result of this. So it's like a correction of the, or the amplitude. So A weighting follow the 40 phone curve. A 40 phone curve, then the C rating follow the 100 phone curve. Phone curve. So C rating is often used when measuring the noise peak. In some situations, we may wish to investigate the peak noise level of an impulse, such as loud bang associated with a sledgehammer blow. C rating give a better representation of the amount of energy contained in an impulse. Impulse refer to this function, sledgehammer blow, a gun, sound. Noise level are often reported as dBA. You get everything DBC, you get C rating or dB, you get no weighting was applied. A noise metric. So this is how we quantify the noise. So a noise indicator or metric is used to reduce a large volume of information about a noise situation to a single number system. It is designed to make the information easy to handle, but still provide accurate information about the noise environment. There are three broad categories of time-varying noise. They are as follow. We have a continuous noise that is fairly constant over time, may be classed as continuous noise, such as the operation of a conditioning unit. We have an intermittent noise, usually at regular interval, like intermittent use of sound in Timberland plant or stop-start of a forklift made up. And there are impulse noise, the noise that carries a sudden sharp sound, a sudden bang of sharp duration, such as the gunshot and sledgehammer blow. So continuous equivalent noise level, this is the first one, noise metric. How do we quantify the noise? Energy-based indicator as it represents the total amount of acoustic energy over the specified time period. It is the continuous steady sound level that would have the same total acoustic energy as the fluctuating noise measured over the same period of time. So L equivalent, then log n 1 over t. So they have a integration from 0 to t over p1 square dt. So t here refer back to time. Where t is okay, the t is the time period over which measurement occur. PT is the instantaneous acoustic pressure and P0 is the reference sound level, which is So the value for reference sound level is 20 micropascal. That one is constant. We have a statistical indicator L10 and L19. So this indicator what the level of noise. Okay. Oh, this is graph for LEQ, continuous equivalent noise level. The time varying noise signal in blue is measured over time t. The amount of energy in the signal is equivalent to the amount of energy contained in the continuous noise level LEQ over this same time period. We did this represented by the red color. Okay, the second one is statistical indicator L10 and L19. This is the figure. So L equivalent is here. Then we have L10 and L19. So L10 represent the noise level exceeded for 10% of the time. L90 represent the noise level exceeded for 90% of the time, and the L90 indicates a term used to describe the background noise level. For example, an L10 uh, 1 hour, L10 1 hour level of 65 decibel mean that for 6 in that hour, 10% the noise level exceeded 65 decibel. 1 hour, 60 minutes. So 10% is, let's say this is 1 hour. What is second? So 1,600 seconds. So the 10% here equal to the 6 minutes or 3,600, 360 seconds. Measuring noise. Standard practice behind the noise measurement. If you refer to this book, there are several more type of metric. Ada banyak. Got the provincial EU noise indicator. That one is for the see, divided into two, either night or day. Lmax, Lmin maximum, Lmin level. Let's refer to the so measuring noise. Whatever method is adopted should usually follow an international or national standard, and most national agencies have a guideline that should be adhered to. For example, measurement may be taken to provide a general overview of the background noise environment prior to a particular industrial development. To check if a wind farm is in compliance with noise limit, to measure the sound power level of a particular source, or to validate noise prediction. All these situations require different methodologies and most likely different noise metric. So first one, a competent person. So in general, a competent person should have a good understanding of acoustic and standard measurement practice ability to interpret result, identify anomalies in result that warrant further investigation. Another one is the sound level meter and calibration. The sound level meter is an instrument that uh, record the level of sound as well as performing additional analysis on the sound to represent usable information to the operator. So all sound level meter must be subjected to regular calibration. To calibrate the sound level meter means to check it respond against a non-sound source. Then measurement period. The duration of measurement campaign will depend on the purpose of the measurement, type of source, and desired accuracy of result. So for road traffic noise, this is based on Europe. For road traffic noise in Italy, a monitoring period of 1 week. Logging hourly is required, whereas numerical assessment of a revenue is required only 24 hours. So each country have their own guideline. Even in this book, there are Spain, what else? For the wind farm. So the microphone position for the noise measurement. The measurement should be conducted at the height of either 0.5, 8.5 or 4 meter. Strategic noise map generally predict noise level at the height of 4 meter. So the microphone is based on ISO 1996-2. The microphone and the sound level meter should be positioned at least 3 meters away from the hard surface to minimize the effect of reflection. So 1996-2 suggests flush mounting the microphone on the effective surface, the backing board method. In this case, a correction of negative 6 dB is applied to represent the incident sound feed to eliminate the impact of reflection. So based on this ISO, we put the effective surface intentionally to the correction. Then we have the extraneous and residual noise. So extraneous source may be present and encountered, for example, from the bird, insect. The residual noise is the sound remaining at a given position in a given situation when the specific sound position are suppressed based on the same ISO. If the residual sound pressure level is 10 dB or more below the measured sound pressure level, so coming back to the definition, sound pressure level is the distance from the sound source. So meaning if you want to measure traffic noise, so the traffic noise, the source itself is the sound power level, and a distance from that source, define it as a sound pressure level. So when the residual sound pressure level is within the range from the 3 to 10 dB below the measured sound pressure level, then the following correction may be applied. So this is the correction associated with the residual noise. This is for sound pressure level 3 to 10 dB below the measured sound pressure level. Sound propagation. As sound propagate away from a source outdoor, it is attenuated through a variety of attenuation mechanisms. Take a simple industrial source as an example. If the receiver is far enough away, the source may be treated as a point source with sound power LW, the sound pressure level at the receiver LP due to the industrial source is simply LP equal to LW minus a total dVA. So attenuation. So attenuation is it absorbs the sound. So the total attenuation represent the sum of all form of attenuation and may be calculated from A total equal to A divergent plus A atmospheric plus A ground plus A protection plus A miscellaneous. So for the miscellaneous, there are many. Wind effect, foliage effect, and temperature effect. In attenuation, miscellaneous attenuation. Just the how the sound propagate. It's a speed. Although this is 2D, but if it's 3D, it's like half sphere. The first one is A divergent. So as sound propagate away from the source, its energy is conserved, but it must be spread out over a wider area. In the case of a simple point source, propagating noise equal in all directions, the energy of the source is spread out over a sphere with surface area 4 pi r squared. The attenuation due to this geometric divergence ADI divergence is depicted from this equation. A divergence equal to 10 log 10 4 pi r squared. So r squared refer to distance. So table 2.7 calculate the value for the attenuation due to geometric divergence over a range of distance. So this is already calculated from 2.5. See the divergence is around 19 decibel. So the further the distance, the higher the attenuation, up to 71 decibel for 1,000 meters from the source. But of course, this is just for reference. It doesn't necessarily the R for your case is 2.5. Might be 1. Atmospheric absorption. As sound propagate through the atmosphere, its energy is usually converted into heat through a number of molecular process. Actually, it's a vibration, and this lead to a decrease in the sound level of a receiver point calculate located some distance from the source. Atmospheric absorption is depend on four variables: the frequency of the sound, atmospheric temperature, humidity, and air pressure. So ISO 9613-1 provide a range of table for attenuation coefficient given a certain value of humidity, air pressure. So let's do that. The general trend is that higher frequency are attenuated at a higher rate due to atmospheric absorption can be calculated based on equation 219, a atmospheric equal to alpha TED is the distance over 1,000 dB. So D here refer to kilometer, but for geometric divergence, R is in meter. So table 2.8 values of alpha for temperature 15 degrees C, humidity of 70% and 1 standard atmosphere. Yeah, any table in SO 9613-1. This is one of it. This on temperature 15, humidity 70%. So alpha dB per kilometer based on the, you can see. And we have a ground effect. The attenuation to ground effect is mostly depend on the nature of the ground over which propagation occurs, whether it is acoustically absorbent or not, and the prevailing atmospheric pressure and sound pressure may cause curvature in the propagating sound. The acoustical properties of different ground surface are expressed through the use of ground factor G, which is assigned a value of between 0 and 1, in for which two types of ground surface are defined. So we have surface is G equal to 0 because it can, but minimally. It cannot absorb the sound. So for concrete water, it's G equal to 0. How about stress and vegetation? G is equal to 1. So this G, you substitute it in equation 2.17 under A ground. Attenuation ground. This value mix of hard and soft ground is between 0 to 1 G value. So in the book, there is some example. Some example in page 43. However, for large distance, the propagation path can be rebound on the terrain between source and the zero, and therefore must be accounted for. Preparation for ground effect are performed separately for the three different defined regions: the source region, the receiver region, and the middle region. And each zone will be influenced by the ground vector coefficient G. So it is worth noting that the ground effect will be subject to a certain amount of variation. Snowfall may change the acoustic property of a ground surface, but the natural cycle of vegetation can change the acoustic pattern of the Alright. So what does it mean? There's a many factor that contribute to value of G, but uh, whatever the condition, the value of G is between 0 to 1. Okay. Some, so the fraction, one of the most common measure for reducing noise is through the use of a noise barrier. Properly designed barrier will reduce noise propagating from source to receiver through diffraction over the top of the barrier or around its edges. Some noise may also be transmitted through the barrier. An important pointer of diffraction is the path length difference, delta. Path length difference is the difference in length between the diffracted path of the source over the top of the barrier to the receiver and the direct path from the source to receiver as if the barrier was not present. So this is the barrier, the source, receiver, this is top of the barrier, and the D is the. So D equal to SO plus OR minus. So D here is equal to the path length difference. D here refer to the distance between S and R without a barrier. So S refer to the distance length. To distance. So for the diffraction, oh, sorry. So most calculation method will provide a very detailed methodology for calculating the attenuation to a barrier. And for any detailed analysis, reader should always refer to the stated PPR. A simplified version is represented here. It assumes no sound propagation through the barrier or around the barrier edges. If the barrier is infinitely long, the attenuation due to barrier may then be calculated from a diffraction equal to 10 log 10 3 plus 14 path length difference divided by lambda, which is the wavelength of sound. Okay. So in the book, page 45, some explanation for the barrier based on ISO 9613-2. Even small gap in the noise barrier can significantly reduce the barrier performance. So ISO 9613-2 specify a minimum the surface density of 10 kg per meter square to ensure minimal sound propagation directly through the barrier. In practice, the location of a barrier between a source and a receiver its height and its length will determine the effectiveness of a barrier. There's a miscellaneous or other effect. We have temperature, wind effect, but all of this except for the foliage. Foliage got the value based on ISO 96-2, table 210, page 47. So based on this table, the attenuation by the foliage is not that significant, you say, yeah. Mostly is two decibel, and but that one is for 4,000 hertz. It is divided into different frequency. The mid band frequency is 13.125, 4,000 hertz. So at 125, the attenuation by the foliage. Foliage referred to the tree, the bushes. So, but it's a very poor noise barrier. Noise and how it's based on chapter 7, environmental noise pollution. In urban areas, unwanted sound can overwhelmingly from road-based transportation, but rail-based airport transportation industrial noise are also important sources. Result from the environmental burden of disease. In Europe, projects show that traffic noise was ranked second among the selected environmental stressor. This is impact of noise to health. Uh, so traffic noise is the stressor. The table 3.1, burden of disease from environmental noise in Europe. Uh, Chapter 3. So table 3.1 show a summary of the of the result from the WHO. 2011 burden of disease from longitudinal study, the result of first comprehensive effort at identifying the impact of excessive environmental noise on public health. The study concluded that 1 in 3 individuals in Europe is annoyed during the time, and 1 in 5 has disturbed sleep at night purely from traffic noise alone. So based on the burden of disease from the noise in Europe, noise induced exposure, this is the impact of annoyance to cognitive impairment in children. So for annoyance, cognitive impact is 7,000. Daily is referred to daily disability adjusted life years. Lost or inhabited in town, or 50,000 population, sleep disturbance, even cardiovascular disease. So dailies are the sum of potential years of life loss due to premature death and prevalent years of healthy life loss by virtue of being a state of pure poor health or disability. Is the unit? Is it a unit? Unit based on the burden of disease reported. So the burden of disease is expressed in terms of disability adjusted life year daily, which is the sum of potential year of life lost due to ill health, disability, or nearly death, and the equivalent years of healthy life lost by virtue of the state of pure health or disability. It is represented by the following equation. So daily is equal to YLD year live with disability plus YLA year of life loss. So one daily is equivalent to 1 year of healthy life loss. But the WHO 2011, what is a burden? It's a methodology consists of calculating the burden of disease on the basis of exposure, relationship, exposure, distribution, population attributable fraction, background prevalent of disease, and disability with DW of the outcome. Attributable fraction is the proportion of disease in the that is estimated to be prescribed. The noise DW factor were used to reflect the severity of disease on the scale of 0 to 1. Okay. I refer to book page 53, 54. So there's a graphic representation that we can refer to. So graphic description of the daily. So we have a healthy life daily. This is a measure of overall disease burden, expressed as the cumulative number of years lost due to ill health, disability, early death, so have a healthy life, equal to year lived with disability plus year of life loss. Significant early death. So the daily was really developed by Harvard University for the World Bank. First used as input to the World Bank World Development Report 1993, interesting in health. Since then, it has been adopted by the WHO as a core metric for measuring the burden of disease in population throughout the world. However, the metric has not been without its critics. With Annan Hansen describing its flaw and its assumption and just value judgment are open to serious question. I think it's perfect. So this is the noise stress relationship and effect overview. Figure 3.3. So we have direct pathway and indirect pathway. Hearing noise, indirect pathway, annoyance, disturbance of sleep, stress indicator, risk factor. Good question. Yeah. A noise activate the sympathetic and endocrine system. Okay. This is more technical. Endocrine system, the pituitary adrenal cortical axis, the sympathetic adrenal metabolic axis. So changes in stress hormone are frequently found in acute and chronic noise experiment. The two principal pathways are for the development of negative and adverse effect. That effect resulting from noise exposure is direct and indirect arousal and activation of the human organism. Okay. So based on this book, the direct arousal or direct pathway refer to the instantaneous, this is based on page 55, instantaneous tension of the acoustic nerve with the very structure of the central nervous system. Meanwhile, the indirect pathway refer to the cognitive perception of sound, noise, its cortical activation and related emotional responses, whereby not only the noise level itself, but subjective effect of noise annoyance has an association with negative health effect. So the indirect pathway start with noise-induced disturbance of activities such as communication and sleep. Okay, baca explanation. So the physiological experiment on human, page 56, have shown that noise exposure, even at the moderate level, act via an indirect pathway and has health outcomes similar to those caused by high noise exposure on the direct pathway. Thus, acute noise effect occurs not only at the high sound level but also at relatively low and middle sound level when rather importantly physical recuperation might be taking place and when activities such as concentration, relaxation, and sleep are disturbed. It is because of this relationship that the EU recommend evaluating the noise ratio as on the basis of estimate of noise annoyance. Okay. That's why in the so here you specifically put annoyance. This is pyramid of health effect or effect of noise from feeling of discomfort to mortality, the highest one. So the number of people affected by the suffer is must be bigger. Then some of them feel stress, causing the blood pressure, cholesterol, then the diseases and mortality. Environmental noise and cardiovascular disease. If you refer to this book, there are many challenges. Starting on page 57, we have environmental noise and annoyance, then sleep disturbance, cardiovascular hypertension, heart disease. Yeah. So it's well known that this is based on page 66. Short-term exposure to environmental noise is a stressor that activate the sympathetic and endocrine system. This may lead to acute changes in BP, blood pressure, and heart rate, as well as elevated level of stress hormone in the body. Over the last 2 decades, a series of studies have produced results which suggest the transportation loss is associated with negative cardiovascular effect. The hyena, hypertension, and exposure to noise near airport 'provided interesting data. 4,861 responded on the effect of aircraft and road traffic noise in a study around 6 major European airports. The study, it does 2008. 2008. Study found a significant increase in risk of hypertension per 10 decibel increase tested in road traffic noise. A more profound dose response relationship was evident for men. What is sleep? heart disease. So heart disease is a patient in which the heart is starved of oxygen. To reduce blood supply can cause a heart attack and angina. A long-term effect of chronic noise exposure at high noise level have been studied in animals, resulting in permanent vascular changes and alteration of the heart muscle to cardiovascular mortality. WHO recently concluded there is sufficient evidence to suggest a relationship between excessive daytime noise and increased cardiovascular risk. So, in conclusion, noise can contribute to cardiovascular disease and hypertension. So we need to mitigate the noise. So a human that suffer from prolonged exposure above 40 decibel for lifetime exhibit a range of detrimental uh, health effect. Noise action planning under the EU environmental noise directive (END) is based on Chapter 7 is the world largest and most ambitious program of strategic noise reduction according to END. The action plan refers to plan designed to manage noise issue and effect. So first action, okay. Noise action plan, this is END, stand for Environment, EU Environmental Noise Directive. The set noise reduction target either in terms of the reduction or reduction in the population exposed above a certain threshold. Describe the measure that will be used to achieve reduction. Establish reduction priorities and realistic schedule for implementation of abatement measures. Outline expected cost of the measure proposed. Outline convention mean and establish the accountability. So this action plan is based on the END. Refer to this book, page 204. So at step for noise action planning. Can refer to chart as well. It's a figure 7.1 overview of the planning process. First is establish responsibility, meaning assigned to individual and agencies. Step 2, identifying existing noise limit value at the national, regional, and local level in individual station or state. Step 3, hotspot are areas where the level of noise is very high or the level of population exposure to noise exceed predefined national limit. Step 4, identifying and prioritizing specific short-term mitigation measures as well as long-term strategies for noise reduction and reduction of the number of people affected by noise hotspot. Step 5, draft action plan. Should provide a summary of the noise problem in the area under consideration as well as an outline of measures that will be put in place to address noise pollution. Step 6, adopting, monitoring, and reporting of the action plan. Step 7, selecting and actively involving relevant stakeholders in a meaningful manner. Step 8, consulting the general public. Source abatement. Okay. But for each of the steps, the book will provide you with more explanation, such as what does it mean by general public health? Step 8. So, consulting the general public, it is crucial that the general public are consulted in a meaningful way because noise action plan rely heavily on the general public acceptance and support for noise abatement measures. After all, those who have to do the noise abatement plan and something is the general public. So achieve this involve consulting the public about noise abatement measures that are being proposed for implementation and receiving the suggestion for improvement and amendment. This process could also involve the general public identifying noise hotspot that may not have been identified as part of the noise mapping process, as well as acting as a validation mechanism for hotspot. So awareness to the public about the proposed action plan to reduce the noise. Yes. So abatement. The most effective noise control and regulation measure are those that target reduction in noise emitted at the source. For a noise control strategy to be truly effective, it must given the duration of specific cases of exposure, attempt to utilize abatement measure that target noise reduction at the source as well as at the receiver. So source-based noise definition. This is the best one is legislation. Then law, surface maintenance, traffic management, tire, law, noise vehicle, and driver behavior. So the most effective, cost-efficient method of reducing noise at source is via the legislation or regulation. So which set up a permissible noise level at the point of manufacture. So this is involved policy. Enforcement of the limit is crucial to the effectiveness of any legislation. The permissible noise limit should be set for the major emitter of noise wording or transport vehicle modes with different limits being set for different mode of transport, as well as outdoor machinery. So for the legislation, go to the book, there's an example. This is EU, page 113. So in EU, the road traffic noise reduction at the source are limited by reducing the permissible sound level of motor vehicle by reducing noise across the entire road network. So in 1970, the Motor Vehicle Directive established permissible sound level for motor vehicle and also harmonized the associated testing methodology. The permissible noise limit is stipulated in the directive range from 74 to 80 dBA depending on the vehicle terminal. So, so for it's between 74 to 80 dB. For Malaysia, yes, we have under EQ, Motor Vehicle Noise Regulation 1987, enforced by the DOE with JPJ and police. So for car, the max sound level is 99. For motorcycle is between 99 to 95. Electric vehicle, tak ada masalah. Okay. The categories range from passenger vehicle comprising less than 9 seat to vehicle tended for carriage of goods with an engine power of not less than 100 kilowatt. Next is the low noise road rail surfaces and maintenance. As mentioned in chapter 5, the main source of road noise are engine noise and rolling noise. The latter relates to the interaction between the vehicle tire and the road surface which generate noise, while the former relate to vehicle engine and transmission noise which propagate from the vehicle directly and also reflected noise from the on the road surface. The treatment characteristic which describe the acoustic behavior of the road surface, surface roughness, porosity, and elasticity. They are responsible for pumping, influencing the excitation of tire vibration and sun radiation from tire. So figure 7.2, page 214, acoustically relevant civil engineering properties of road surface. So type of road pavement, we have dense and porous. Type of binder is the same. The mix is mineral aggregates. Okay, the same. The surface treatment, si Papa faham civil work. Okay. Low noise road surface. The ability of a surface to attenuate noise depend on a number of factors, but key factors are the type of the surface, the texture, pattern, the degree of porosity of the surface structure. The most effective low noise road surface currently available are porous asphalt and thin layer asphalt, while there are a number of next generation surfaces currently showing some additional noise reduction potential. Porous asphalt and thin layer asphalt. The porous asphalt reduce the air pumping effect and reduce the noise reflected from the vehicle. What is input? Because of it, attenuation capacity which absorb reflection. Another one is the thin layer asphalt. The porous layer is more suitable for urban areas, as the porous layer can get clogged with dust quite quickly, negating the ability to absorb noise. So for both surface, the noise reduction effect is based on the lower aggregate size with 20 to 25 A void in width of the mixture, which has a greater attenuation capacity for noise absorption. As a result, the surface absorbs noise and rainwater, thus less water spray is absorbed by road user and overall noise is reduced. The single layer porous pavement has an average noise reduction of 3 to 4 decibel on highway in relation to dense asphalt concrete. Two-layer porous pavement has a noise reduction potential of around 4 decibel or more. So this is the porous asphalt. The water can absorb into the pavement, but subject to clogging, easily clogging, easily clogged. Another one is the low asphalt solution. They also tend to be expensive. Mm, okay. Because of low noise, road surfaces relative to the other major relatively low with double layer or stability of between pound per meter square or more than conventional surfaces. The low noise asphalt has an additional advantage over to either mitigation approaches such as facade insulation in the indoor and outdoor noise affecting or building near treated properties is reduced. In 2009, the Dutch Center for Transport Navigation, along with the Danish Road Institute, conducted a joint research project assessing the performance of a available low-noise road surface type. The goal was to identify pavement with the potential to reduce rolling noise by 10 dB with respect to the Dutch reference road surface. The project will identify a poroelastic road surface produced by Yokohama and Nippon in Japan. So this is the road. This is type of low noise road surface type. So the measurement results suggest a reaction of 10 EP for facilitator. Although similar improvement for every requires like to human to be possible. Mm, overall, the project concluded none of the available ready-to-use commercial product are capable of providing desired 10 dB noise reduction. Because the goal for this the rod is to reduce 10 dB based on just reference rod surface. In order to attain such reduction, a new surface with more porosity and or a wearing cost with an elastic skeleton need to be developed. I'm not sure now. Still any rod cages surface use 10 dB technology. So railway noise. Rolling noise is the most prominent source of noise when train engineers terminate when they are stationary or traveling at low speed. Large amount of train result from the interaction of steam wheel with steel rail. When a train is in motion, both the wheel and the track vibrate by creating noise. One general approaches to controlling noise. And its source. The first focus on the engine noise of the train itself, which can be abated generally through improvement in the field. Where all locomotives are replaced with low noise locomotives, the second relate to the rolling noise. This is engine noise. So for the rolling noise, the track and wheel irregularities can raise noise emission level by anywhere between 10 and 20 decibel compared to a reference condition. Defect in the wheel thread because of portion of the wheel thread due to mechanical or thermal fatigue. Uh, rail and the wheel absorber to absorption reduce rolling squealing noise, which can lead to 3 decibel reduction in noise. Acoustic grinding to support rail tracks thereby reduce friction. The objective of rail grinding is to maintain and extend the service life of the rail. The process involves applying abrasive grinding stone to the surface of the rail. This is rail acoustic grinding. This is the result. The process involves applying abrasive grinding stone to the surface of the rail to quickly remove corrugation bursts and against this defect. So this can reduce up to 3 decibel. Another method is the continuously welded rail. It's not emission by moving rail joint and therefore impact noise. Jointed track candidate between 2 to 5 decibel more noise than the continuous welded rail. The amount of rolling noise radiated by the track can be reduced by using the damping of the rail of Hyun rail damper. So this is the rail damper. This is the jointed track. The damper is damper reduce the amplitude of the vibration. So amplitude is the y-axis along the rail, thereby reduce the noise radiated can reduce up to 6 decibel. The dampers. Then another way is to improve the brake technology. A new composite brake block technology, including the K and NL blocks. Then cast iron brake block has the ability to reduce noise emission by 8 to 10 dB. This type of noise department measure involves retrofitting the fleet or a portion of the fleet to the new brake block technology. Then the shroud or wheel cover for the train can reduce up to 3 decibel. So have a noise emission from modern train, light train, at least 10 dB less than older train, assuming a 30-year old 30-year lifespan. Further way to reduce train noise in city is to have, where possible, a long track. This is example, a long track. This increase the surface emission of rolling noise from the train and reduce potential reflection. So low parallel wall close to the tramway can reduce noise considerably. For example, 3.5-meter wide configuration of 16 parallel walls starting 1 meter per stack is predicted to reduce railway noise by more than 6 decibel. The 1 meter high receiver deteriorated from the region of the track. Some of the effort is using a low noise tire. Study found a range of somewhere between 6 to 8 dB within certain tire subcategories and 10 dB within the entire car category. Some of the different in acoustic performance 700 tires. Utilizing the best tire technology, which could be fast tracked into the vehicle through the introduction of. Yes, so it should be legalized to enforce the policy to reduce the permissible noise limit. In Europe, noise rating provide external noise ensure the tire in the same document. Okay, that is it. Then decide to low noise tire, we have traffic management. The most important measure of our reduction in traffic volume, and particularly the volume of heavy vehicle reduction in traffic speed. So if traffic speed reduces in city, it is vitally important that average speed are not allowed to increase. Very often, noise reduction achieved in cities and beyond as a result of reduction offset by the increasing traffic speed because vehicle can travel faster on less busy roads. In 2011, study found that banning private car in the city center reduced noise level by only 2 dBA because as a result of buses increasing their speed due to less congestion. Okay. So reducing speed between 100 and 130 kilometer per hour lead to no reduction in noise. So here, for heavy vehicle, like cars, only one decibel. It's only below 100 kmh that you can measure in must have significant reduction in the actual driving speed. Traffic calming measures. Speed bump, while they do reduce average speed along road lane, so tend to increase the number of acceleration and deceleration along the link, which offset the reduction. Another way is a one-way street. It will improve the flow of the traffic in cities with the flow of traffic. So it less acceleration, deceleration, which reduce the noise emission. Another alternative is the nighttime traffic restriction. So 27% of the okay, 27% of the circulation was exposed to LDEN, LDEN frequency. It's under it's under noise matrix. LDEN refer to day, evening, and night. So LDN is day, evening, and night. Greater the value above 70 dBA by almost 85% exposed to L night greater than the WHO GDBA. So for LN, it's referred to time period of 7 to 7 a.m. to 7 p.m. And evening is 7 p.m. to 11 p.m. The L night is 7 p.m. to 7 a.m. So 10% travel demand has been expected reinforced via nighttime traffic section. A noise hotspot along the specific reference route on the broad network. Population exposure above 40 dBA during the night time would be reduced by 5% using this traffic measurement measure. The propagation measure. The role of land use planning in noise abatement is often underestimated. The potential use in noise abatement lies in their ability to indicate quiet areas that are to be protected against noise emission, to design noise as the area from strategic noise mapping to land use planning. Okay, so this is land use planning to look at land use in such a way that to promote modal transfer from private to public transfer cycle and work. So this is planning, land use planning. This is how to propagate the noise. So first through the noise compatible building. Use of noise compatible building as noise barrier which can be achieved through the land use planning and development control process. So the best practice include utilizing building that are not noise sensitive as noise barrier for sensitive building. So this practice we can see it hospital, yeah. Meaning there's a or housing area. So the noise abatement can be achieved through the careful extension of existing commercial building to act as a barrier to more sensitive building. In hospital, they put this parking spot to to protect the hospitals. The building design. Okay. So what about how the building design, the specific area where building design can improve, can influence noise emission, noise inside the building include room layout like this. This is the noise compatible room layout and geometry and orientation of the building. Room layout should ensure that kitchen associated with less noise sensitive activity, kitchen, bathroom, utility, and storage are placed toward the noise source. A rod or rail line, while room that house more noise sensitive activities such as bedroom for sleeping and the living room for relaxation are located away from the noise source. That's why some of the housing, they put kitchen in the front door. It's they apply this with design to reduce the noise travel to the noise sensitive room like the bedroom, living room. Only we found it in apartment layout. Next is the geometry in orientation of the building. So the definition of a building like this is to be avoided. This is should be preferred. So building like this, we can see it in front of the airport, yeah, the hotel, which is will be reflected the noise inside the and the geometry and rotation of building should be primarily planned design consideration in relation to the indoor noise Level not only within the building under the presumption ownership, but also other building within the vicinity. The extent of reflection. Extent of reflection is the primary calculation for geometry and orientation of the building geometry and orientation should be designed in such a way that to minimize potential reflection from the key noise source. Then we have a balcony and wing wall. This is measured to propagate the noise. Balcony. Orienting window away from the noise source. And protecting them with wing wall is also the perspective acoustic design. Enough reduction partition balcony range from 5 to 10 dBA, depending on the width of the window. So for this type of noise reduction, normally we found it in hotels or apartment. They put this wall of aluminum shape or wing wall, that is. The depth of the balcony and the height of the then the noise barrier. The noise barrier normally we found it in highway, peninsula. Noise barrier generally seems to be an effective mean by which the propagation of noise can be mitigated. Highway, the railway station, railway track, or LRT, they pass through this residential area. You notice it will slow down a bit, or they put a barrier possible. So those really only seem to be effective mean by which the propagation of noise can be mitigated. The first proposed real noise barrier are built in California in 1968. Frequently used to reduce noise propagation alongside the road or railway line. In fact, noise barrier include earth berm are the dominant type of mitigation measure in confluence of European Director of Road, which is traffic. So earth berm, macam tanah, the slope. Contoh is the example in figure 728, page 228. So based on ISO 9630, limit the maximum attenuation of thin noise barrier at 20 dB in any octave band and 20 dB in case of thick noise barrier. However, in practice, the noise barrier will reduce noise level by 3 to 7 decibel, depending on their design and height. Barrier are relatively ineffective at screening properties. At some distance from the road, as the barrier is not additional to the attenuation due to propagation over the intermediate of ground instead of area replacement. component of noise attenuation. Road noise barrier. A simple reflecting barrier will often used along road and rail line, but modern barriers tend to have absorptive surface on the traffic side, which minimize the level of reflected sound. So it can be in any material, acrylic, wood, concrete, rubber mat. In CEDR member state, concrete, wood, and aluminum are the most prevalent barrier type. So absorbing barrier, a barrier with absorptive material on the inside of the on the traffic side of the barrier. They serve to absorb some of the incident sound and thus reduce reflection that might impact receiver of on the opposite side of the road. However, research in the UK has suggested that reflection from the noise barrier has a small effect on noise level on the traffic side. You have this cap barrier. This is cap barrier. So the barrier is specifically designed cap section at the top of the barrier. Functions to reduce the potential of sound wave traveling over the top of the barrier. I mean, so 1994 study conclude that average increase in acoustic ceiling of 2 meter high T-shape multiple edge double barrier compared with the simple plain reflecting barrier of identical height can reduce up to the difference between 1.4 to 3.6 dBA. Not by adding the cap can get more 1.4 or to 3.6 more dBA reduction. Then we have the embankment or earth berm. These are natural barriers that can be created for a material dump out during the construction phase of a new building. Not only vegetation can also use as a noise barrier, however, their effectiveness in terms of noise reduction is minimal with 10-meter depth of vegetation resulting in only 1 decibel reduction in noise. So how do you know that one is referred to the attenuation under miscellaneous foliage? Tu berapa hari? So that's the thing, yeah. Under the outdoor sound propagation. Yes. Table to 10, page 36. So it's based on the foliage and it's a distance. But the highest is 1 decibel. Yes, sorry, 2 decibel. But the one is specific for the 4000 hertz, the frequency. Other than that, it's 1 or 0.01. Design consideration, the barrier must be sufficiently tall so that it blocks the line of sight between the source and the receiver. Yes, that is correct. The length of the nose barrier must be long enough to cover an angle at least 160 meters from the receiver. So this is how it's this is the barrier. This is the receiver. So the height of the length of this barrier, the height of the barrier at the top to the receiver angle is 160. X rule of thumb. The most effective barrier are solid tenuous, where a break in the barrier is necessary. The barrier should overlap. If you need to, there's a break, then you need to overlap. A barrier placement in relation to the noise is critical. The barrier contain no leak due to hole, crack, gaps, and so on. This leak basically will compromise the acoustic effectiveness of the barrier. Another one is the sound tube as well. Sound tube we can refer to book page 230. Okay, this one is found in Australia. Next is the sonic crystal. A sonic crystal, a collection of thin beam positioned in a manner to scatter sound wave at specific frequency. Example of a sonic crystal is the kinetic sculpture by this artist, Juan Mas Foundation in Madrid, Spain. So in 1995, acoustic tests were performed on this structure, and they show that capture a good attenuator of sound at certain frequency due to the spacing of the beam. So this is a sonic crystal. Then the building or facade insulation. This sound insulation of building include soundproofing the window and outer wall, particularly at the facade of the building, which is directly exposed to noise. Modern window with double or triple glazing can reduce noise by somewhere in the region 30 to 40 dB, but for triple glazing, normally we found it some of the high-end hotels. One of it is KLIA and Summer Hotel. The wall insulation. A solid well-fitting door can achieve noise reduction between 35 to 40 decibel. Sound isolation can be linked closely to improve thermal insulation. Insulation placed between the vertical member of an external wall will play a significant role in reducing sound transmission through the wall. Thus, the two are compatible, and insulating building for energy improvement also has the effect of reducing internal noise level. The result from a recent Norwegian study found that average noise reduction inside the dwelling of 7 decibels in on facade installation. Then we have some case study. calculation. Okay, so this is some calculation with exercise example. Okay, I think we continue next week. Just some of the noise with example and calculation. This is based on Handbook of Military Engineering by Lawrence. So, attendance. Any question? Ask me now. Later I will the video assignment is next week. The midway assignment. Check